Hello, today we're going to talk about the laws of exponents. All right, so the laws of exponents, here are your basic laws of exponents, so you can pause the video and go through them as a review. So let's jump into some examples. So example number 1, it says write a power of 3. So we need to write it as a power of 3. So we have 81 times 3 to the power of k. Well, 81 written as a power of 3 is 3 to the power of 4. And if we have 3 to the power of 4 times 3k, remember when you multiply like bases, you keep the base and you add the exponents. There's my answer as a power of 3. All right, number 2. It says express in exponent form with a prime number base. So when you think about having a prime number base, a prime number is a number that can only be divided by 1 and itself. Okay, so when you think of a prime number base, the number that you can end up rewriting this as is 343 is the same thing as me having 7 to the third power. 7 is a prime number. So whenever I say that I want to have 343 to the power of x, I can change 343 to be 7 to the third power and keep the exponent of x. Now, when you raise a power to a power, you multiply the exponents, which means that we will end up having that 7 to the third power to the power of x is going to be equal to 7 to the power of 3 times x. So that is written with a prime number base. All right, so number 3, it says express in exponent form with a prime number base. So remember, prime number base, it means that you want to write it with a base that can only be divided by 1 in itself. So a prime number is 2. So I can rewrite 4 as 2 to the power of 2. And I can write 16 as 2 to the power of 4. So what I can do here is I'm going to replace what is on the inside. So if I have 4, I'm going to write 2 squared because 4 is 2 squared, and that's to the power of 2w. And then instead of having 16 to the power of m, I can rewrite 16 as 2 to the power of 4 to the power of m. So now I use my laws of exponents, and it states that when you raise a power to another power, you multiply the exponents. So we're going to have this as 2 to the power of 4w divided by 2 to the power of 4m. Now remember, when you divide like bases, you keep the base and you subtract the exponent. So that means we're going to have 4w minus 4m. So this is my expression written with a single prime base. All right. Number 4, we have 3 to the power of a negative 1. So remember, when your exponent is a negative, it means to flip or have the reciprocal. So where we have 3 to the power of a negative 1, I'm going to rewrite that as a reciprocal because that's all the negative means. Okay, it means the reciprocal of 3 to the first power. So 3 to the power of negative 1 is going to be 1 over 3 to the power of 1, which is just 3. We don't have to write the understood 1. And then we have minus 3 to the power of 0. You should know that everything to the power of 0 is 1. So if I do 1/3 minus 1, that's the same thing as doing 1/3 minus 3 over 3, which is equal to a negative 2/3. Number 5, we have a power raised to another power. So remember, you want to raise everything to the power that is on the outside, meaning that you are going to distribute the exponent on the outside to every exponent on the inside. So remember, the exponent on the -2 is an understood 1. So we're going to distribute this 5k to the 1 and to the 3. So we're going to end up having -2 to the power of 5k, because 1 times 5k is 5k. And then we're going to have p to the power of 15k. So that is how we are going to simplify that. We cannot simplify this any further. And actually, we can simplify it a little bit further, because we know that -2 to the 5th power, if I wanted to write it, I can write it as -2 to the 5th power to the power of k. Okay, and it'd be times p to the power of 15k. -2 times itself 5 times is a -32. So this is the same thing as having me -32 to the power of k times p to the power of 15k. Number 6, remember, a negative exponent literally means you are going to take the reciprocal of what's inside. So when I do that, I am going to flip what is on the inside. So we have f divided by 2w to the 3rd power, and we're going to raise it to the 4th power still. So remember, a negative exponent just means you have to flip it. It means nothing else. And now we are going to distribute that exponent of a 4 through to every single exponent. So that means every exponent on the inside is going to be multiplied by the 4 on the outside. So this is going to be equal to f to the power 4 divided by 16, because 2 to the power 4 is 16, w to the 12th power. Number 7. So number 7, it says we have to simplify the numerator. Anytime we simplify the numerator, we need to do whatever operations it states. So the numerator is being multiplied. So when you multiply it like you do normal with the numbers in front, your coefficients. However, when you multiply your like bases, you add the exponents. So 8 times 9 is a -72. And y to the 4th power times y to the 11th power is going to be y to the 15th power. And then we have to raise everything in the denominator to the power of 2. So we're going to have -2 squared, and then we're going to have y to the power of 6. So we know that -2 squared is -2 times -2, which is a positive 4. So we're going to have 4y to the 6th power, and then we're going to have -72 y to the 15th power. So once again, move back to the properties. We have to divide. So we will do -72 divided by 4, which is a -18. And then you have to, when you divide like bases, you have to subtract the exponents. So that means you're going to have 15 minus 6, which is going to be 9. So we're going to have y to the power of 9. So next, number 8, it says write without a fraction. So if I want to write it without a fraction, then that means that I want everything to be in the numerator. So 3 to the power of 3 is going to stay in the numerator. Okay. Now, in order to get this denominator and to flip it, or to take the reciprocal of it, because if I want to flip it, that means I need to make my exponent negative. So if I do that, what's going to end up happening, if I want to bring this up to the top, is that I need to multiply by 3 to the power of a negative exponent. So that's going to be -8 minus 4n. So I want to make the whole exponent negative, all the parts of it. So when I do that, I see that I end up getting 3 to the 3rd power times another 3 to the power of -8 plus 4n because I'm going to distribute that negative. And then last but not least, when you multiply like bases, you keep the base and you add the exponents. So we're going to have 3 plus -8 plus 4n. And we already know that when you have a positive and a negative, it's just a minus. So when we do that, we end up getting 3 to the power of -5 plus 4n. Or you can say 4n minus 5. It's the same thing. Okay. Let's look at number 9. So number 9, it says we need to write without fractions. So everything in the numerator in number 9 should be divided by x. So we're going to have x to the power of 3 divided by x minus 4x squared divided by x plus 7 divided by x. And we want to write everything without fractions. So remember, when you divide, you subtract the exponents. So the exponent, if it's not written, is an understood 1. So x to the power of 3 divided by x to the power of 1 is going to be x to the power of 3 minus 1, which is x to the power of 2. Then we're going to keep our subtraction sign. 4. X to the power of 2 divided by x to the power of 1. Subtract the exponents. We just have x to the power of 1, or you don't have to write it. And then last but not least, we have 7 divided by x to the power of 1. We can't subtract exponents because the 7 doesn't have an x. However, we know that we can write it without a fraction by bringing the x to the top, aka put the reciprocal. So this is going to be plus 7 times x to the power of -1 in order for us to not have fractions. Okay. Number 10. Here we want to make sure we don't have any fractions, so let's do it. We have 3v to the power of 6 divided by v to the power of -3 plus v to the power of 4 divided by v to the power of -3 minus 5v divided by v to the power of -3. So remember, when you divide like bases, you subtract the exponents. So I'm going to have 3 and then v to the power of 6 divided by v to the power of -3. We're going to have 6 subtract -3, which is going to be v to the power of a positive 9, because 6 minus -3 is the same thing as saying 6 plus 3. All right. And next one, we have v to the power of 4 divided by v to the power of -3. So that's going to be a positive. Keep the v, and you need to subtract the exponents. So that is going to be 4 minus -3, which is going to be 4 plus 3, which is 7. And then last but not least, we have negative 5v divided by v to the power of -3. So v to the power of 1, and we're going to keep the 5. So we got a 5, bring that down. V to the power of the understood 1 minus v to the power of -3. We're going to subtract those exponents. So 1 subtract -3 is 1 plus 3, which is 4. So we're going to have 3v to the power of 9 plus v to the power of 7 minus 5v to the power of 4.